Hi, this is Dr. Siddaling. I am expert in machine learning and data science. Today, I am going to discuss about LSTM based time series prediction, our work. So, the link of this particular paper is given below. You can go through this particular research work and also cite this to your work and the research for the references. So with this one, let's start with working on LSTM model for oil price prediction. And what are going to be the objective? So this is a univariate oil prediction model using the LSTM. So that's what we are going to build. That's the first objective. And to carry out the sliding window for the training and testing for the time series. And then we will also look at the scalar normalization and the standardization scalar that are present in the Sklearn pre-processing module. So, continuing further, as you know that we cannot apply the random split as we usually do it in the case of image processing or any other data, because there is a inherent connection in terms of the dependent values in the time series. So there is a correlation that is exists between the first value and the previous value. So therefore, we cannot randomly split and apply the cross validation. So how do we address this particular problem? So we can apply three different techniques in order to perform the train test test split. That is the first technique, and then there are two more technique that I am going to discuss. In the first test, first type of technique is that given the entire data, we will divide it into training and testing separately. So these two are separate out, and the first part of the training having the all the dependent continuous values are kept, and that is going to be used to train the model. And the second part of the test data that is going to use the validation as well as testing the model. So you can have a different proportionate of this train as well as the test portion, and then go for building the LSTM model. And these are the two different other two different techniques. One is called as sliding window technique, another one is expanding. Let me take the pen so that I can write it and pinpoint. So first one is a sliding window. In this particular sliding window, we have fixed number of samples. We will take it out, and these samples are used to train the model. And the next few sample or a single sample usually could be used to test that particular model. So this is how the train as well as the what is going to be the output, and that testing is determined by the next sample. So this will continue. So we will take up the next few samples, maybe say 14 samples. If we have taken the 15th one, will be the output that it is going to be decided, and it will continue again. We will take out the next 14 and so on. But in the case of the expanding window, the is in initial sample we will take, say suppose 14 number of samples, and the next 15 sample used for it to test its value, and it is going to be expanded by including the fewer new samples. So we will expand the previous content of the window along with the new samples, and that is going to be used to train the model. And you can see the size of the remaining part, the test size, the sample which is used to test the given model is going to remain the same. So this will be the same throughout the number of windows that we are selecting in the both the cases of sliding window also and expanding window as well. So continuing further, two different standardization what we are going to see. One is called as normalization. The equation for the normalization goes as shown here. So given a sample x, we will subtract it by minimum value of the data series, and then divided by taking the difference between max and min. So this is what we will get it as a normalized value. So we can achieve with the help of a function called as MinMax scalar that is present in the Sklearn pre-processing module. And there are three steps are very essential when we are applying this min-max scalar. First one is to fit this scalar on the training data, and then followed by apply it on the training data. Once it is fitted, we have to apply it on the training data, and then followed by apply also whenever you are predicting, you have to apply the scalar and then go for the predicting, and that it will give in the scaled value, so it will not give in the actual original values. So therefore we also need to apply the inverse, whatever the values that is predicted by the model, then we have to do the inverse of that, and that will give us the original value. So that's how the overall procedure, both the type of scalar. The second type of scalar that what we are going to see is standardized data. So there is a slight difference between the standardized data and the min-max scalar. So during the standardization procedure, so we will take the difference between the mean and then divide it with the standard deviation. So that's what the difference. The function called as standard scalar is that is present in the sklearn preprocessing, that can be applied on the data to achieve the standardized data. Again, these three steps are common, so you have to fit the data on the data, and then followed by apply it on the training data, and also when you are actually want to predict it, so apply it on the prediction before predicting the and then also you have to perform the inverse of whatever the values that is predicted out. So with this one, we will continue to look at our code, what I have written, and to demonstrate over here. So let me show the data sample, how it is looking data sample. So this is the type of data sample what we have here. So this is basically a univariate data sample consisting of the price values, and these are the various date and the year and month. All this information is present. So this particular data we are going to read with the help of the pandas. So we will have these different modules such as NumPy, Keras is going to use for the deep learning model to build. Pandas is again another model that we are going to use it for the reading the data and processing the data. So, and pre-processing is achieved with the help of Sklearn pre-processing module. So, and this is the usual way I will change the current directory in order to retrieve the data at a particular location. So you can also follow the similar way, and then followed by this PD read CSV is a function which is going to read the data into data frame. So we create the data frame oil in the DF oil. So let me run each one of that, and then take a look at it, how the data frame itself is created. So let me go through each step and quickly running out in importing all these modules. And this is to set these two function I'm going to explain after a little while. So let me run it and keep it ready, and I'm going to change the path of the current path using the chdar, and then it will locate the current directory where the data and the code is kept. And then followed by that df pandas read csv is going to read the csv file into df oil, that is the data frame. So let me run it. So this is our data frame oil, that is what it looked like. So this is how it is read into the data frame by the pandas. So these are the values. So altogether there is 1013 values with the indexing starting from 0. So it is total 1014 values are present over here. So the second step what we are going to do is changing the date time. So usually sometimes maybe CSV file could be read as a string sometimes, so we will require to change it to the date time format, the entire column. So we will apply it date time and then it will be converted. So we can also print out and look at the some initial values. So these are the different initial values of the oil price. So you can take a look at it here, and then followed by this we can now apply the plot curve. So this is a very simple function that I have written, taking the x as the data series and y as the range of that particular series. and taking the X label and Y label as well as the series label. So this will just use the plot and set the grid, what type of values has to be presented along with the legend, and it will show the plot. So let it plot it the our initial data series. So this index is very useful in order to show it for the x-axis. So it is the defining the x-axis for the entire. So it is the range from 0 to 1014, and along this particular index values, the entire series is going to be plotted. So let me call this plot curve and show how the data series is look like. So this is how the entire time series is looking like. So this, you can see there is a fluctuation, and then there is a slight values are come down, and then there is a lot of fluctuation at the end. So let me close this part, and we will convert to the oil price to the float values. So this is requirement to perform the next scalar values. So as I explained to you, there are two different scalar we are going to see today. One is standard scalar, another one is min-max scalar. Let us apply the first min-max scalar, and then again we can uncomment this particular, again rerun this particular entire code to check whether there is a change in terms of the prediction or not. So may not be very much evident when it is a small data set, but it is very much evident when you are having a bigger data set and then you want to check out the what is the total error, and like MSC error in the predicted as well as the real values. So there we can also analyze what is the impact of min max. So this will create the min-max scalar, and we will fit it on the training data. So this fit function is going to fit the on the entire training data, and then followed by we have to apply this on the entire training set. So this is going to apply it on the entire training set. Now it is very interesting to see both the curves, the original entire data set, and what we have scaled version of the data series, so that we can do with the help of plot to curve. So this is again a simple function that I have created over here, taking the two curve values x1 and x2. These are the x-axis values for the curve, and followed by y1, y2. These are the actual curves which have to be plotted. So let us plot it out, both the scaled as well as the original time series data, and look at how both are looking. So you can see that there is a lot of fluctuation that is existing within the range of say 40 or maybe 38 somewhere here, and ranging to 80. But on the other hand, this particular after the scaled price values, you can see it is just came down, and all the fluctuation is also not visible. But if it is scaled to between 0 and 1 itself, it is possible to look into the variation that is present in this particular entire data series. So this is what exactly happens when you perform the scaling. So after that, it is very important to apply the sliding window. So as I explained, the window size is created. So we will pick up those many number of samples for the training, and then next one sample for the prediction, and this will be continued, and then till the entire data sample is covered. So we will take out two values. One we will call what it is going to take as a input values, and what it is going to be predicted. So oil py, that is the price value. So that is the forecasting value what we want the model to give as an outcome. And we can define the different window size. So we can change the window size, maybe here 15, 16, or 20, depending on the your data size that is present. So initially we will take out the one sample I want to forecast. So that is the next after 14th, what is going to be the sample that I am going to predict. So that is indicated with the next prediction value, and window size is 14. So 14 samples are used to train the model, and the next one is to predict based on those 14 initial values. A for loop is used over here, taking the initial ranging from window size till the length of the data frame, and each time I will pick up the 14th value, 14 values, and kept in the from the scaled version of the data frame in the oil px. So x is the input that is going for the model, and this will be continued till the last all the samples are taken from the given data frame. And the next immediate next sample after 14, that is 15th value, will be appended in the oil py. So this is going to be used for predicting those used by the model to predict that particular value. And we will also convert, let me run this particular for loop, and you can see the different oil px as well as oil py are created. So this is a basically list. You can see these are the values that are coming. So each one unit will contain 14 by 1 value. So that is a particular list that is appended, and this overall number of training samples are created. And similarly, you can also see the size of the oil py is also 1000, and this is also 1000. So this is very important because it has to be same size, then only we can show it to the model, and then model will learn on these samples. So you can see that this is a single value that is has to be predicted. So this is the 15th value. So after every 15th and so on, multiple of those values are fetched, and this is how this is to be forecasted by the model. So after that, we will convert into the array. So NP array, that's what we will create it. Now we can plot, we can also see what the size and shape of each one of these data frames. So initial size was 1014. So that is the size what we have it in the data frame, and the size of two number of column. One is for the date, another one is for the price. Second one is after scaling, what is the size what we have left. So because we only picked up the price value, the number of columns are now reduced to 1, and then followed by the size of the training x in order to train that in terms of the sliding window. So we have 1000, and then followed by 14 because 14 samples are picked up, and 1 because that is the one column of the price. Similarly, what is the size for the uh, oil prediction? What that is 1000 by 1, because the after 1000 there is a 1000 such samples, and then 1 to be predicted by the module. So we will initialize the module with the help of Keras sequential. So we will create a sequential model, and this is also another very important because we are using particularly for the LSTM. 100 units of the LSTM neurons are considered, and activation is ReLU here. And what should be the input shape? So what is input shape depend on what vector you have created over here. So while px is the input for the uh, LSTM model, so we have to consider same unit. So this is 0th position, and the first position is 14. So 14 by 1. So 14 such sequential information that are fed to the LSTM model, followed by the only one to be predicted, or one to be trained on. So that's how we will take it. And the return sequence is set to be true because it is the next layer is also LSTM. Because it is the next layer is LSTM, we have to set the return sequence to true, and then we will take another add layer with and then we will add the next LSTM layer. So there are again 50 units of neurons with the activation ReLU, and this one we will set the return for the second layer as false, indicating that after this particular layer there is no LSTM layer that is included. So next one is to drop out to enhance its generalization capability by reducing the overfitting. That is the one technique to you apply the drop out, and then finally we will take the dense layer. Again, important to know that what should be the shape of this particular dense layer, how many neurons should be present in the outcome of the dense layer. So that is indicated with the help of oil P. So because that's what we are, our outcome prediction. So that is 1. So this is how we will set overall entire deep learning model. So we can also compile. Let me execute all of these sentences, and then let me also compile the entire model here. And then we can also take a look at the summary of this particular model. So this is how the entire model is look like. So this is our first layer, LSTM, and then followed by the second one, third one is a dropout, and the final one is the dense. Now we can train this particular model with the help of fit function, and it also returns the history. So history indicating the both the loss error as well as the validation error. So let me run this one and take a look at it. It would take some time based on how many number of epochs you have set. Intentionally, I have taken a very few epochs so that it will finish very fast. Quick training would be possible with the help of 5 number of epochs. So you can see that there are validation error and the loss error that is being reflected over here. Now the same history information we can use it, and we can plot both these curve, the one curve with the loss and another curve with the validation loss, with the help of plot two curves. So we can plot it. So index is how many number of iteration that is went through over here. So we can plot it, and this is how the overall both the losses during the training process took place. So you can see the validation error is pretty low from the beginning, because it is estimated after few number of iteration going through the all the samples. So initially this will be the first 14 samples, so you can expect the error to be high, but it will come down as the number of iteration proceeded over here. After this particular training the model, we need to forecast the with the help of the given sample. Now I want to forecast 30 number of samples, so that I can pick up from the last 30 samples of the training data, so that we can use it and perform the prediction. So let me take the last 30 days. You can set different values here, maybe 15 days or 7 days. So that amount of prediction that model has to be performed. So we will take up the prediction using the predict function. Now it is basically performing the prediction, and then it will give the prediction these values in terms of the uh, uh, not original values. So these are the values within the range of 0 to 1. Now, when you take a look at these values and the original data frame, so this is my original value of the data frame. You can see here it is ranging from 50, 60, 70, and these are the actual oil price value. So there is a difference between what it is being predicted. So you have to always apply the inverse transformation of whatever the scalar you have chosen. Now, the inverse transformation will bring back to the original range of values. So let us do that particular process. So let me keep it at the variable exploration, and then inverse transformation is being done with the help of inverse transform provided by the scalar. And we will also plot these two curves. Okay, one that is actual values. These actual values are obtained by say suppose if I open this one, so last 30 days. So these are the last 30 days till here. So indicates the our uh, actual values. So that one I will show with the predicted values. Let me compare with what is predicted and the actual values by the module. And we can do it with the help of taking plotting both the curve with the help of plot two curves is a function. So let me run this and see how both are showing. So now you can see this is how the overall prediction is being achieved. and we can now plot the final 30 samples along with the training samples, initial bunch of training sample, and then the last one only with the predicted values. Now you can, if I run this particular part of the code, now it will show how much these are all the blue colored samples are training samples, and then the last one, few samples, 30 samples, are predicted by the model. Now let me change the type of the scalar here. So initially we use the min-max type of the scalar. Now let us go for the standard scalar. So let me mask this second one, and I can also use the standard one. So let me comment the one which I'm not using. So if I run the overall code and take a look at it, what it's going to show as an outcome, any difference between the outcome because of the type of scalar we are using, it may not be very much evident, especially when there is a fewer number of epochs and fewer samples are used. But as you have a big data size and more number of iterations are carried out, so the scaling has a lot of effect. So you can compare with your own data set and then decide which one has to be used. Now, this is a kind of outcome that is given the pretty much more or less same with the what previous min-max also gave the very close difference between the predicted and the actual values. Now you can also see here the this is the original training data, and then followed by the last 30 samples are predicted outcome. Now this is very much connected, and it is also following the type of pattern. Now, with the help of this particular taking example of the oil prediction, I have today explained the LSTM model along with what it is going to have an impact when we change the scalar. And if you have any suggestion, comment, please write and let me know. I can, based on your comment, I can improve upon my video. And I am very uh, happy to know that you are taking interest to know these various concept of machine learning. And thank you one and all to watching these videos. Thank you.